quite surprised. She was off a bit before I was ready, but anyway, gear up, climbing away, looking good.
G'day, I'm Phil from Philtech, and in this video we're continuing on with the manufacture of the crankcase from the Leslie V12 engine. We're going to start with the turned billet and end up with the billet milled and drilled with holes and tapped with threads. So for the first process, we're going to use a face mill, and a face mill is really good for making flat surfaces on a machining centre. So let's have a look at that operating. Here we have the 4-axis machining centre. The crankcase billet is mounted onto the 4th axis rotary table. This facilitates machining from all sides, except of course the front and rear. The cutter is spinning at 1,590 revs per minute. You can see the 4th axis rotary table indexing the material to the next position. So for tool 2, we're using a 10mm end mill, and we're going to use it to rough out large amounts of the material from the crankcase billet. So let's check this out at the machine. We start with circle milling to rough out for the holes for the cylinder liners. Now we're going to rough out for the carby body. Finally, we're going to rough out from the bottom for the crankshaft area. So for tool number 3, we're going to use a long series 6mm end mill, and we're going to use it to mill deeply down the interior, and we're going to actually use it to do the finishing cuts as well. So let's have a look at that on the machining centre. You can see the automatic tool changer loading in the next tool. We've rotated the crankcase billet to 180 degrees. We're using the 6mm end mill to do the final machining of the interior for the crankshaft area. The cutter is running at 5,000 revs per minute. Okay, we're up to tool 4. We're going to use a ball-nosed end mill, and we're going to use it to mill the contour around the top of the crankcase. By the way, all the end mills are either solid tungsten carbide or carbide insert tools. We use the ball nose end mill because it gets rid of that square-edged block shape. It makes it look more like a casting. And remember, of course, the V12 engine is from that almost Art Deco era of 1940s design. We run the cutter at 5,000 RPM for the roughing part of the process, but when it comes to the finishing, we drop the cutter down to 1,000 RPM and just do one pass. We now use the bottom of the ball nose cutter to smooth out the flat area at the base of the profile. Tool 5 is a smaller version of the ball nose end mill, a 4mm one. And we're going to use it to do the more intricate profile around the sides of the crankcase. The 4mm ball nose cutter is used in a similar fashion to the 5mm ball nose cutter. It is essentially continuing on sculpturing the crankcase. It's vitally important to keep the weight of the engine to a minimal amount. So these small cutters are a great way of removing every bit of excess material you can. Tool 6 is a 4mm chamfer tool, and we'll be using it to chamfer the various edges around the crankcase. Tool 7 is a 22mm reamer, and we're going to use it to give a precision hole for sealing the O-ring on the carburetor body. A reamer is a great way of getting an accurate dimension and a really good surface finish. Tool 8 is a 3mm corner radius tool, and we're going to use it to put the 3mm radiuses on the mounting lugs on the crankcase. There's no actual practical reason for the radius, it's purely for aesthetics. Tool 9 is a spot drill, and we're going to just spot drill for all the various holes on the casing. Tool 10, a 1.8mm drill to drill for the M2 threaded holes. With these tiny drills, you need plenty of woodpeckering and the spindle speed as high as you can do. Tool 12, a 2.7mm jobber drill. We're going to use this to drill the holes for the M3 threaded holes and give a bit of clearance for some end milling. Tool 13, another thread form tap, the M3. Tool 14, 3mm end mill, and we're going to use that to machine away some of the excess weight on the crankcase. The final tool, tool 15, a precision boring head. This is to bore for the cylinder liners. The boring head has a replaceable carbide tip with a positive rake angle. It can be adjusted by microns. This really is a cool looking tool. Well, that completes the work for the 4-axis machining on the crankcase. Next video we'll show you what we do at the front and the back of the crankcase. If you've enjoyed the video, remember to like and subscribe. Otherwise, see you next time. If you want to know more about the Filtech Leslie V12 engine, check out our website at www.filtech.com.au.